Hello and welcome to today's flipped instructional recording. Today we are covering lesson 1.06, work and changes in energy. So just a reminder as we get started, if you struggle with note taking, listen for the parts of the lesson I tell you to add to your notes page. You can pause the video at any time if you're jotting things down. I will be covering the guiding questions, so be sure to jot down those answers as we go along. And please don't forget to create a slide or a page, however you're doing your science notebook, every time you read through a lesson. So that way you are not forgetting the information and having to do it at the end. So as we get into the lesson today, why do work? So we've talked about machines making work easier, but why do work at all? What are you accomplishing when you do work? And how does work done on an object change that object's energy? These are the types of questions you will answer in this lesson. Try to complete a statement below as you progress through the lesson. Use the graphic organizer to fill in examples of different types of work. You might also want to include sketches and ideas of work. So the graphic organizers are not required, but they are very helpful in helping you put together ideas from the lesson. So you can add them into your notebook if you would like. You can even submit them with your notebook if you would like. But I definitely encourage you to open them up and go through and try to fill them in as you go. It just helps the concepts that we're talking about in the lesson to make more sense. All right, you have one keyword as of now to define, so go ahead and put that in your notes. Potential energy. We know that that is stored or available energy. It's also the energy of position. And here are our guiding questions for the lesson. So I'm going to open up a Word document and just stick those over to the side. Just take a little snip of these, and that way I'll have them as we go through. Let me see. Here we go. So if you don't have the snipping tool or the light shot tool, it is really handy. I know I say that every time. So the first thing we're looking for is what is displacement. All right, so now as we get into explore, this is where the lesson content actually is, and there is the very first guiding question. What is displacement? So force leads to displacement. Remember that displacement is the change in position of an object. So there you go. There's the answer to guiding question 1. And number 2 says, when does it occur? So it can be positive or negative. It is different from distance in that it has direction and only takes into account the initial and final position of the object. So we're thinking about that. Work happens when you apply a force, and the force causes the object to be displaced. So what happens as a result? There are a couple of possibilities. So take a look at these situations and think about how work is being done in each case, and in particular, look for the direction of the force and the direction of the displacement of the object. So this is something that might be good to jot down some images or take a screenshot and put in your notes with some words that explain the difference there. So we know displacement is taking into effect the change of the position of the object, right? And when does work occur? Second question, guiding question 2. Work happens when you apply a force and the force causes the object to be displaced. So very important. We got guiding question 1 and 2 answered, but this also would be, if you're answering the question, you don't have to put it in your notes. But some of these images might be a good idea to add. So going upstairs, let me see if we start. And then you've got an elevator descending. Okay, so in the examples, remember, we're looking for the direction of the force and the direction of the displacement of the object. So where did you start and where did you end? In the picture here, Start at the bottom of the stairs, you end at the top. So you are displaced. In an elevator, you're starting in one place and going down, right? The elevator is being maybe pushed down, or you could see if it's being pulled down. So that displacement there. Catching a baseball, so you can see where the ball ends. We can't see the pitcher or where whoever threw the ball, but we can see that it ends here. Throwing the baseball, so the force is coming from the person throwing, and then we saw the person catching. Shooting an arrow, so you have a starting point and an ending point. So none of these are going in a circle, like stopping and starting in the same place, like when you're running on a track. They all have a different start and end point. All right, so let's talk through some of these. How is height related to work and force? That's the third guiding question that we're looking at. So let's kind of think about that as we're looking at the picture here. So in this situation, a woman is carrying a box up the stairs. What direction is the force she is applying? So she's applying a force upwards against gravity. With each step, she's pushing up. What direction is the distance she travels? So as she walks up the stairs, she goes diagonally upwards. Some of her motion is upward and some is forward. So know that when you're talking about direction, it's not necessarily just north, south, east, west. It can be up, down, left, right, diagonally. So any word that describes the direction would be a directional word. So she's going diagonally upward. And then she applies force upwards, and some of the distance she goes is upward. So those are in the same direction. So she is doing work. And then what does she accomplish? So here, when she's finished climbing the stairs, she and her package have moved to a higher location. So how is height related to work and force? So if we kind of think about that and read this last little paragraph, one thing that can happen when doing work is an object can be moved to a higher position. But what about going down the stairs? What is different? So for number 3, how is height related to work and force? We know that we're applying force upwards to go up the stairs, and that we're also going directionally, right? We're moving in that upward direction. So that is the answer to number 3, how height is related to work and force. And number 4 talks about what is the difference between positive and negative work. So this talked about going down the stairs, or now we're looking at an elevator. So think about whether or not cables perform work when an elevator that is descending at a constant speed. So what forces are there? So gravity provides a force that is downward, but the cables provide a tension force that is pulling it up. So you can imagine kind of those arrows in your head with the different forces up and down. So what forces are there? Sorry, that's what we just saw. Remember, you are focusing on whether or not the cables are doing the work on the elevator. So think about the direction of that force. Tension in the cable keeps the elevator from falling, but it also lowers it at a controlled slow speed. So what direction is the elevator going? It would be going down. And what direction is the tension? The tension is pulling up. So imagine holding up something and lowering it very slowly. If you imagine grabbing onto something with your hands, it would be that same kind of thing. You've got tension because it's really heavy. You're pulling up. The object would be going down. All right, so going on, throwing a baseball. So when a pitcher throws a baseball, the force of the pitcher's hand on the ball is applied over a given distance. At the beginning of the motion, the ball is at rest. When the ball leaves the pitcher's hand, it is traveling very fast. Where did that acceleration come from? So the acceleration occurs because there's an unbalanced force acting on the ball, and that's the hand pushing the ball, right? is this positive or negative work? So the pitcher applies a force forward and moves the ball forward. This is another case of positive work. This time, instead of gaining height, the ball gains speed. So number 4, what's the difference between positive and negative work? So now we've understand positive work, right? Something's going forward. So that helps us get ready to answer that question. So let's look at the example, catching a baseball. So what about the catcher? What happens here? Think carefully for a second. When you catch a ball, what direction is the force? So the force is in the opposite direction the ball is traveling, right? So you're reaching out maybe to catch it. So you're going forward, the ball's coming toward you. So those would be opposite directions. When you catch a fast moving ball, think about what your hand in the glove does. Right? So it's got to react to that. It can't just stop and have no motion. That would break your hand. Your hand's kind of absorbing some of that energy from the ball. So as you catch the ball, your hand gives a little and it moves in the direction that the ball is traveling. So is that positive or negative work? So catching a ball involves applying a force in the opposite direction of the distance the ball travels until it stops. So this means that the work the catcher does is negative and causes the object to lose speed. Okay, so the force is coming out, it is grabbing the ball. Even though the ball has to give a little bit, it has stopped that forward motion, so that's why it's negative. So the difference between positive and negative work, that is coming up. You'll see it on the slide. So in the direction of the force and the direction of displacement of an object determine whether positive or negative work is done. So these directions also determine how the object's height or speed change. So how does this happen? So if you're able to go through the examples here, you can move these things. So this is talking about positive or negative work and what it causes. So this force, displacement, or direction, you're just putting the boxes where they go. So we know positive work that causes the object to gain speed. Negative work causes the object to lose speed. That one's here. We know it also loses height as well. A force is upward and the displacement is downward. So this one's talking about force. And then positive work that causes the object to gain height. So like going up the stairs. All right, so we can check that. Uh-oh, look at all of these that are wrong. Oh, we've got to match them. I think that's why I was just putting them in. I wasn't matching them. I did not read the directions carefully, right? So a force is upward and the displacement is upward. So positive work that causes the object to gain height, that's going to go up here. Those would match. So negative work that causes the object to lose height. So that would be, this one we might have to move. Can we move it? Force is downward, lose height, it goes here. And then a force in the same direction as the displacement. A force, so think about that, it's in the same direction as the displacement. So if it's going in the same direction, it's going to gain speed. But if it's going in the opposite direction, like the baseball being caught, it's going to lose speed. So now let's check those. Okay, I didn't read that carefully at first. All right, so the difference between positive and negative work could be the difference in the object gaining or losing height or gaining or losing speed. So we can see that in all of these positive and negative work, and that is what answers question number 4. So now we're going to loaded with potential. And question 5 of guiding question says, what's the difference between kinetic and potential energy? So have you ever shot a rubber band across the room? What did you do first? You stretched it. So you applied a force to the rubber band and stretched it a distance. Can you see how this involves doing positive work on the rubber band? The direction of the force and the direction of the rubber band stretched are the same. Positive work means the object has to gain something. So what does it gain? What two things have you seen an object gain so far? We've seen it gain height and speed, right? Is that correct? Height and speed. And then, does the rubber band gain either of these? So no, it hasn't, but you know it's gained something. The rubber band is now ready to be shot across the room. So pulling it back and holding it, it didn't get higher and it didn't gain any speed. So what's happened with that energy? All right, so connecting work and energy together. Work is defined as applying a force over a distance. Energy is defined as the ability to do work. So doing work on an object can change its height or its speed. And so how do these concepts connect? Doing work on an object changes the object's energy. And there are different types of energy: potential energy and kinetic energy. Potential energy can be thought of as stored energy. So when an object's height changes, its potential to fall also changes. This is a form of potential energy. When a spring or elastic material stretches, like a rubber band, it has potential energy that also changes. So in this case, the potential for rebounding back is increased. So remember, think back to that elasticity we talked about way back in semester A. What makes something bouncy and it's elastic. So think about that energy changing. And then when an object's speed changes, so does its kinetic energy. Kinetic energy is called the energy of motion. So the faster something moves, the more kinetic energy it has. So the difference between kinetic and potential, okay, potential energy does not mean the object is not moving at all. It just means that its position is going to affect how much potential energy. So the more height something has, the higher the potential energy. If it's on the ground, we know that it can't really fall very far, so its potential energy is not high at all. But if it's really high, like on top of a building, we know that it could have a lot of potential energy. So that's the difference there. And kinetic energy is when it's moving. So the object has to be moving to have kinetic energy. And the faster it moves, the more kinetic energy it has. So how is potential energy converted to kinetic energy? So if you look at the picture here, you can kind of see a good example. Potential energy, the apple is up in the tree. It's got more potential energy here because of its height, right? And that's why it's got potential energy. It's not moving yet, but as it falls, the potential energy is going to decrease, but it's gaining kinetic energy as that speeds up. So now we're looking at the conversion between the two. Sorry, my slide won't change. So work and energy are kind of a loop. Consider a very normal activity, hammering a nail. The hammer is raised high and then swung down. Work is done on the hammer to raise it up. The work gives the hammer additional potential energy. And when it swings down, that potential energy is converted to kinetic energy. So as the height decreases, right? So when it swings down, that potential energy changes to kinetic because then the nail moves. So the hammer has the energy, which is the ability to do work, and the hammer does the work by applying the force to the nail, driving it a distance into the wood. So can you think of any more examples of work changing an object's energy, which in turn allows it to do work? All right, so let's look. Positive or negative work. So that last guiding question, how is potential energy converted to kinetic? If we go back, make sure we got that answered as that loop, right? The form of potential, then it springs back. It talks about, let's see, I think I went one too far. It talks about the loop here, right? And it talks about the addition of potential, and then it swings down, how that's converted to kinetic. So, and then that causes movement. So that's that loop it's talking about, that conversion of potential to kinetic. So make sure you have that answered for number 6. And then going into this last slide here, in which of these situations is there positive work and in which is there negative work? Remember that positive work causes the object to do one of the following things. It's either going to gain speed, which remember is kinetic energy, increase in height, that's potential energy, or it's going to stretch, which is also potential energy. So conversely, negative work causes objects to lose speed and decrease in height. So you can practice with these. You're basically just moving the ball to where it goes. So a ski lift carries people up a mountain. That is positive. The people gain height. And so you can check that. A skydiver's parachute is opened and he's going down. So he's losing speed and decreasing in height. That's negative, right? So you can go through and practice these as well. And then just check and make sure you understand that concept. You may want to put these things in your notes. If it's positive work, remember that it gains speed. It gains kinetic energy. I would also put that it increases height, which that means it increases potential energy, and it stretches, which is also potential energy. And then I would also put in my notes that negative work causes objects to lose speed and decrease in height. Okay, so there's some things to wrap up in your notes. And then as you're reviewing, some more things to put into your notes. Remember that work involves applying a force over a distance. You have that definition several times. The direction of the force and displacement determines if work is positive or negative. And that determines if the object gains or loses speed or height. Okay, you may want that sentence in your note. In the case of an elastic object like a rubber band, work can become stored energy when it stretches. So all of these things so far are good. Maybe you want to add them as bullet points so they're not running together. And then in each case, the work is changing some kind of energy, either kinetic or potential. And so it gives you some more examples just to ask questions and see if you understand, so you can check yourself on that. And then make sure that you have all of these things updated on your slide. So in wrapping up, look for the flip follow-up session on your Class Connect schedule. Remember, that's a great way to connect and pull some of the concepts together. Attend Help Lab. If you need extra help, you can also send a Skype message or an email, and have a great day.